Well, let's take a look at the Gonset G-76. This is a new radio to me, and we're just starting to clean it. Not too bad. You can see some crud over here on this. It looks like a coupling blocking cap here. Mica. May have to take some solvent or some alcohol to that. The rest of this is going to clean up with soap and water pretty nicely. This seems to be an early version. This is the 16 tube version, which does not have. Well, I'll say one thing that's unusual about this G76 that you don't see in many radios is that there's a lot of wiring and components above the chassis. Because they have shoehorned so much stuff in here, it's not unusual to see a little bit of the plate circuit above the chassis in a radio, but it's pretty unusual to see the bottoms of the tubes and their associated wiring above the chassis. And we certainly do see it here. And that makes, what it means is when you have a perforated cabinet like the G76 has to have for cooling, that all the dirt, accumulated dirt, can get in here, and usually it's just going to land on top of a chassis, and there might be a couple of switches or controls that can get some dirt in them, but not much. But here we've got the bottoms of the whole modulator section, including this voltage regulator, the bottom of the final amplifier tube, the whole cathode and grid input circuit is all exposed. And I have to admit that I don't know what this is, but I think it might be the VFO tube or the driver. Let's see, it's going to the plate circuit, and golly, RF choke plate circuit. I really am not quite sure what it is. I don't know why the driver would have a capacitive feedback to that tube. I don't know. I'll have to find out what the heck that tube is. I'm really not sure. Could be the part of the receiver circuit, because the receiver shares the tank circuit. The front end of the receiver shares the transmitter tank circuit. Though I don't know what it's marked V4. But anyway, what it means is that this particular radio is going to need frequent and careful cleaning to avoid any kind of shorts that can or arcing that can develop because of dirt that falls in here. It's the same old story that I always say, that dirt and high voltage will attract more crud, and dirt attracts moisture. You get some dirt on something and it absorbs moisture from the air, and then you got high voltage present, so you got electrostatic attraction of more dirt, and pretty soon you create an arc path. So this, more than most radios, is going to require careful cleaning and periodic cleaning if you don't keep it covered. Now, if you use this radio in the shack, which I think most people will do in this day and age, you can do what I do and just keep a cloth over it. You keep a cloth over it, the dirt doesn't settle in the radio, and you only have to clean it every 5 years instead of once a year. But anyway, it's going to be a particular issue on this radio because of how it's constructed. Okay, here's another very dirty tube base, and I'm going to clean that the same way. I'm going to go after it with alcohol on a toothbrush, being careful not to damage anything like this RF choke. These have very fine wires and you don't want to mess with them. But I want to get this clean, and then I'll go in with the paper towels and the little tiny screwdriver and to try to do more detailed cleaning. Of the clamp tube and they added a clamp tube and a 12AQ5 and I think a 12BY7 is a keying tube. This one has 350 volts cathode from the finals current on the key jack, so I don't think we'll run this thing CW. On the newer ones they added that circuit so they were keying the driver tube to get the voltage down on the key to something reasonable. Anyway, no obvious modifications or golden screwdriver in here except for that one little electrolytic in the back. The previous owner said he tested all the tubes, but I'm going to double check those, make sure nothing went back in the wrong place, and make sure they're really good. Power supply is another deal. There's some electrolytics to change in there. Right now we're just washing it and looking for anything wrong while we're doing that. Okay, the usual considerations apply when you're getting in here, cleaning all the little nooks and crannies and crevices with soap and water. Here in the final amplifier section, there's going to be high voltage. B plus on this thing is 600 volts, but at peak modulation it's going to go up to 900 or 1000, at least 50% increase. So there's a lot of high voltage here, and you want to get this thing clean. This thing's been sitting on a bottom shelf in a workshop for at least 5 or 6 years, so it's dusty, but because there's high voltage here, this tends to electrostatically attract dirt anyway. So I removed this tube, and this tube has a clip on here because this is a mobile transmitter, so it won't come out. So you've got to push both of these things down so they're not grabbing the tube race while you pull the tube out with the other hand. But you want to get in here and remove the tube so you can get any dirt off of the RF choke here. And this yellow loop, I believe, is a 6-meter neutralizing capacitor. I don't think it's an antenna coupling. In fact, I'm sure it's not. I think this is the neutralizing capacitor for the 6-meter section. If you really want to disturb that much, you're gonna end up touching it, trying to get that clean in there. So you may disturb the 6-meter neutralization a little bit in the process of cleaning it. So just be aware of that, and don't diddle with that any more than absolutely necessary. But you want to get all this stuff clean. There's RF, a lot of RF here, and high voltage also. So you want to get it all clean so there's no arcing. I haven't seen these little brown phenolic plate caps in much of anything else, but they used them over here in the modulator too. Kind of cute. At first, when you look at the layout on the top of this thing, you think, well, it seems to be a little cobby, but they really have put a lot in here. Receiver, modulator, transmitter, oscillator, VFO, all that stuff crammed in a 12-inch wide chassis. They did pretty well. But when you get down here and look at this, this is gorgeous. This is really nicely done. This was, it's not a Collins, it's not a Morrow, but it's very nicely done. I think this cost almost $400, not including the power supply. It wasn't cheap. And that's $1961, so that's a quarter of the price of a new Volkswagen or a fifth of the price of a new Chevrolet. Not insubstantial. The other thing, I misspoke when I said that little cap on the bottom was in the audio circuit. Here's the whole audio circuit up here. The audio driver, the output stage, the modulators are all here. So there'll be some, there's, I can see one little paper capacitor in here. There'll be some capacitors in there to get after as well. Anyway, just be careful while you're cleaning, and you won't have any trouble later. I think this must be the socket for the crystal calibrator. That's the only plug-in option I know for this thing. So that must be what that is. Another thing to do is pay particular attention to what tubes you're taking out of where and where you put them back. Now here's two identical looking tube sockets with identical looking retainers. One of them is an OB2, a voltage regulator, and one of them is a 12AQ5, an audio tube. You do not want to interchange those. You don't want to be mistaken. So it's best to have a manual, but if you don't have a manual, you better put them in some physical order where you remember what they are. Take a piece of paper and write it down. You can even take a laundry marker and write right on here what tube goes where. It'll come off with alcohol later, but it saves you from making expensive mistakes that can damage your radio or blow it up. So every radio's got its peculiarities and places that you have to be particularly careful. If this was a Valiant, I would know every nook and cranny of it and been able to tell you. This is a new radio to me, but here's one thing that you can kind of count on a lot of radios. You see that the wires that come out of this modulation transformer actually have cloth insulation on them. It may be cloth over rubber, but it's still cloth insulation, whereas most of the wiring in here has plastic insulation. Well, what does that mean? It means one thing, that you don't want to get it soaking wet when you clean it. I'm using rubbing alcohol here because it evaporates a lot better and faster than the soap and water that I'm using elsewhere. The other thing is that you kind of want to be careful if you try to move these leads around. You'll see that these wires are right up against the envelope of this OB2. Now if that was a tube that got real hot, like a 6AQ5, I would have to move those wires. I couldn't leave them. But I know an OB2 is just a voltage regulator tube. It's just an ionizing gas tube that don't really get very hot. So I'm not going to worry about it. But if you get in there and try to move those around with your screwdriver, you can damage the insulation on there. And because it's a modulation transformer, you got 1,000 volts on the got the B plus going through there at 600, and when you add the audio voltage on top of it, it goes up to at least 50% higher, which is 900, and probably 1,000 volts there, not uncommon. So you want to be careful not to damage those wires, and been working all this time. There's no arc marks. Clean it, but don't damage it. Okay, I've just had an initial go at this, but you can see it's considerably cleaner than it was. So you ask, well, how the heck do you get into a place that's that tight? Well, I'm using rubbing alcohol. I took the cap off a pill bottle, filled it full of rubbing alcohol, took a clean toothbrush, dipped it in there, and got the toothbrush in there, and got at everything I could without wrecking everything. You can't get too deep until you start messing stuff up. Then I took a clean paper towel and my little fancy German screwdriver and used the paper towel and the screwdriver and got in there between all the tube pins and all that junk. And look at all the crud that came off on this thing. This is not a smoking radio. This is just dirt that's gotten in there from whenever the last time it was cleaned. We know it's been sitting in somebody's workshop on a bottom shelf for 5 or 6 years. We know that, and it could be 20 years or a lifetime. We don't know. But anyway, worth doing, and that's how. Well, here I am working on the cleaning the modulator audio section of the G-76, and I pulled out the tubes and in order to clean it better, and I'm glad I did, because you'll notice that they've got a lot of perforations in the chassis here. This allows cool air to come up over the bottom of these tubes. We got a 12AQ5 in here, a 6CM6 audio driver and output tube here, and a pair of 6DQ6 modulators. Those are basically 25 watt plate dissipation sweep tubes. So there's quite a bit of heat right there. A 12AQ5 or 6AQ5 is basically a 6V6 in a tiny little 7-pin package. And it's one of the hottest miniature tubes in terms of bulb temperature that I know about. I've burned myself on them quite often. So that tube is capable of getting very hot. And I don't know about the 6CM6, but I think it's probably about a 5 or 10 watt audio tube. So it probably gets fairly hot, and the 6DQ6s will get pretty warm as well. So but in here I was able to get at the underside of this wiring and clean it that goes to these push-to-talk switches in here. There's two muting and push-to-talk switches in there, and so I'm glad to be able to get to that. This ceramic-bodied paper cap is rated at 3,000 volts, and it's right across the plates of these two modulator tubes. So good luck replacing that if it's bad. But there's, all the B pluses there. You're going to be looking at 600, 900 volts there on peaks. And in cleaning this cap, one of these plate caps came right off in my hand. So that means that this was on its way out anyway. Not well soldered or been bent too many times, whatever. One of the reasons for getting in here and doing this cleaning is you get to inspect everything, and here's something that was going to fail. That thing could have just broken and been, and stayed right there because it's a pretty solid piece of wire, and been hard to find. Could have broken, could have arced, could have done all kinds of things. So one of the reasons you should clean these things is to find faults in the radio. And when you go through here, and I'm using paper towels with soap and water and alcohol, and go back and look for these little things that you have inadvertently left in there. I snagged a paper towel on the edge of this loading cap right on one of these fins here, and that's short the damn thing out if you don't catch it. So be careful while you're doing this, not only not to do any damage, but also not to leave behind any little wet pieces of paper towel as a calling card to short things out. One of the reasons to do this, of course, is to get rid of any dirt, grease, and crud where there's high voltage or high voltage RF, so that you eliminate the possibility of any arcs. Getting to this all has to, you can see how dirty that is. That all has to be cleaned. I'll probably end up using some Q-tips in there, but you do not want any dirt in there to allow any arcing to happen. Will not be a happy day for you if you don't attend to that. So once you get that soldered in there, you can put it back together. Now, if you play your cards right, you can test the tube and the tube cap and find out that the glue holding the tube cap on is all dried out, and the thing will come unsoldered. Then you got to scrape and tin this and hope you can solder the plate cap back on, and then put some hot glue on it and hope that'll hold it. And this is why we have old dental tools, so once we get the solder on the top cap, we make sure we get the hole clear. Get the tube cap bearing all on the glass envelope all the way around. Make sure the little tit from the plate wire is sticking through the top. Then you can solder it. Then I'm going to take a hot glue gun and put a little bead around the bottom. I probably could get it hot and try to do it now, but I'm going to do it after the fact. So there's the plate wire soldered back on the plate cap, but there's no real connection to the envelope, so if you twist that at all, you risk breaking the wire, breaking the envelope, ruining the tube. So now I've got to do something to make that cap mechanically attached to the envelope, so I'm going to use the hot glue gun. So there's a repair. And you can see that now there's some mechanical strength to it that's not depending on the solder. Okay, looking at the underside of the Gonset G-76, and there's really only 3 obvious capacitors to replace in here. Here's a little electrolytic here. Here's a Black Beauty paper capacitor, probably a cathode bypass cap because it goes to ground over here in the IF stage. And here's a little paper capacitor, probably, what's the value? Another cathode bypass cap, probably in the audio section. I see a little electrolytic hung on the power socket here in the back. It's obviously new. I have to look at the schematic and see what that is. But that seems to be the sum total of the capacitors that you'd want to shotgun on this G-76.